All right, today we're going to be learning about variation. The first thing we're going to talk about is the constant of variation, or the constant of proportionality, and this is usually represented by the letter K. Direct variation means that something is getting multiplied by our constant of variation, and this is usually represented by the equation y equals K times X. If direct variation has multiplication, what should inverse variation have? It's going to have division. And then joint variation means we have more than one variable going on. So it's going to be y equals, or sorry, we're not going to use y for that one. We're going to use z equals k times x times y. And we could have joint variation could keep going on. So which of each of these situations would represent direct, inverse, and joint variation? So if we have points for a touchdown in a football game, the more touchdowns you score, the more points you score. So this would be direct. The price of a movie ticket versus attendance. This doesn't really happen anymore, but the more people you have attending an event, the less the ticket price costs. So therefore, this is inverse variation. Then the refreshment income for the number of stands and the number of people and $2 hot dogs. Well, you would multiply the number of stands times the number of people at those stands at each stand times the $2 hot dog, so that would be a joint variation. Now, if we're trying to figure out the K value, the constant of variation for points for a touchdown in football, since technically a football is worth 6 points, K would be 6. If you wanted to say K was 7 because they typically get the extra point, yeah, you could include that too. Either answer's fine. Not going to be that technical on a quiz. So let's write some equations based on the variation that's described. So it says W varies directly. That means W is going to come before the equal sign. It varies directly, so K is going to get multiplied with whatever's next. The cube of M, so M cubed. Q varies, so that means Q equals, it varies jointly, so we know we're going to have multiple things being multiplied with K, so K times A and B. Z varies directly, so Z equals, now let's look at this carefully, varies directly with X and inversely with the product of W and Y. So that means K has to be multiplied with something and it's going to be divided by something because we have direct and inverse in the same equation. It's directly with X, so X will go on the top with K, and inversely with the product of Y and W. So that means Y and W are being multiplied on the bottom. So being able to write those equations are going to be the first step of our next type of problem. If Y varies directly with X, so that's step one. Start at the beginning. Okay, let's put that into an equation. Y varies directly with X. Okay, then we can go on to, and Y equals 12 and X equals 15. So let's plug those in. 12 equals K times 15. We're going to use this information to find K. So divide by 15, divide by 15. We get that K equals 4/5. And now we can rewrite our equation. So now we know specifically for this situation, Y equals 4/5 X. Then we use the last part. Find X when Y equals 21. So 21 equals 4/5 times X. To get rid of the 4/5, we're going to multiply by 5/4. Those will cancel out. If we do it on that side, we also have to do it on this side. And we end up getting that X equals 105/4. So basically, first we wrote the equation, then we solved for k, then we rewrote the equation, and then finally answer the final question. All right, so let's look at another one. First step, write the equation. So if g is inversely proportional to the square of m, so g equals, inverse means k over the square of m, so m squared. Next, we're going to solve for k. So that's where the g equals 3 when m equals 4 comes in. 3 equals k over 4 squared. To solve, we'll multiply both sides by 4 squared. We get that k equals 48. Rewrite our equation. And then answer the overall question. Find g when m is 6. Nice thing is, we don't have to solve anything, or we don't have to move anything around. You can just type that one in your calculator. We get that g equals 4/3. All right, on to word problems. I know these are all your favorites. So, first step in all word problems, after you read it, of course, is going to be to define the variables. Tell me what variables you're using and tell me what they stand for. I don't really care what letters you pick. Just tell me what they stand for. So, in a certain manufacturing process, the cost of producing a single item varies inversely with the square of the number of items produced. So the two things that we're going to have to define is the cost of producing a single item and the number of items produced. I personally like using C for the cost and N for the number of items. Some people, because it says the cost varies, like to use Y for that and then X for the number of items. That's fine too. You can use your initials, whatever you want to use, just make sure you know what they are and write them down. So the cost varies inversely, so K over the square of the number of items produced, so N squared. So the next step, which was the first step in our previous problems, is write the equation. So what do you think we're going to do next? We're going to find K. If 100 items are produced, each costs $2. So the cost is 2 if we have 100 items. Multiply by 100 squared on both sides. And we get that K equals 2,000. Step 3 done. Next step, as it was before, rewrite the equation. So the cost equals 2,000 over N squared. And then answer the question. Find the cost per item if 400 items are produced. So we're looking for the cost. K stays over 400 items squared. You actually get that cost equals 0.125, but we're talking about money here and we can't have 3 decimal places, so we'll say that the cost is 13 cents. So $0.13. Since we are doing word problems and we're talking about real life stuff, you need to make sure that you include units in your final answer. So you could read it as $0.13 or you could write 13 cents. Just make sure you don't have the decimal there if you're writing the word cents. All right, we're going to do one more word problem. So step 1, define your variables. Things we're talking about in here. The number of vibrations varies directly with the square root of the tension and inversely with the length. So those are our 3 variables. I personally am going to use V for vibrations, T for tension, and L for length. So the number of vibrations varies. So V equals directly with the square root of the tension and inversely with the length. If the number of vibrations per second is 5 when the tension is 225 and the length is 0.6, that's all our information to find K. So 5 equals K times 225 over 0.60. To solve, I'm going to simplify the square root first. 5 equals K times 15 over 0.6. Multiply both sides by 0.06. We get that 3 equals K times 15. Divide by both sides by 15, and we get that K equals 0.2. I'm okay with you leaving it with a decimal here, leaving it as a decimal here, because otherwise we're going to be dealing with fractions inside fractions, and that's not real pretty. So rewrite our equation. V equals 0.2 times the square root of T over L. And then finally answer the question. Find the number of vibrations per second when the tension is 196 kilograms and the length is 0.65 meters. So vibrations equals 0.2 times the square root of 196 over 0.65, so that we get that V equals 4.308. Since we had decimals given to us in the word problem instead of fractions, I'm fine with you leaving your answer as decimals. So basically just follow what was in the problem. Rounding to 3 decimal places is fine when you have a long decimal that goes on. And then finally make sure you include your units. So this was vibrations per second. That's all for